Good afternoon and welcome to our next lesson in pre-calculus. This lesson is on function operations and composition of functions. This is lesson 1.6. All right, so to begin with operations with functions, we need to understand what we can do with functions. So you guys are used to seeing f of x and g of x, and we have all of these functions that we've been working with. But now the question is, what can we do with them? Because sometimes one function isn't enough to deal with what we need to do. So here you can see we can add two functions. We can subtract two functions of x. We can multiply two functions of x. And we can divide two functions of x as long as g of x is not 0. So this may change some things as we're going along. Now, in each one of these cases, we are doing the exact thing with the functions. So if you see something like f plus g, that means it's f of x plus g of x. And I can tell you, as you get higher up in math, we stop writing the x's entirely, and we just say f and g are two functions of x. And then we'll do everything with f and g, and we'll drop the x because it gets tiring to write. And as I have told you, mathematicians are lazy. So we have functions of all kinds of letters, and we simply don't write them. We state at the beginning that it's a function, and then we're done with it. Anyway, let's practice some of this. So we're going to do all 4 operations on these two functions. Here's f, and here is g. So first I want to do f plus g, okay? F plus g. And these are, of course, both functions of x. So that is going to be x minus 4 plus the square root of 9 minus x squared. And no, we can't square root these. Even though you look at 9 and you can take the square root, and you look at x squared and you can take the square root, you can't just square root them. Because if you factor this, you get 3 plus x and 3 minus x. So there is no square root. And now we can simply take away our parentheses. There's nothing to simplify. X minus 4 plus square root of 9 minus x squared. Now, one of the things as we go through this is you have to be able to find where the domains are possible. From here, this is all real numbers, but for this one, it's all numbers except, well, let's see, if you have anything higher than 3, so this is from bracket -3 to 3. Because if I go anything higher than 3, my negative is more, and then this is not defined in the real numbers. So even though this part of the function is defined everywhere, this one is not. So my domain is only going to be defined from -3 to 3 because it's restricted by this square root. Remember, we're only after real numbers. Okay, how about f minus g? F, that's a really crazy looking f. Let's try this again. Need my eraser. Pen. All right, so f minus g. Okay, again, these are both functions of x, but I'm showing you what it looks like when you don't write the functions. Okay, if you don't write the x's. We've defined them up here, and we don't always write the x's in the future. And f, we have x minus 4, and then minus, and then we have g, which is the square root of 9 minus x squared. And then we take away the parentheses, and we get x minus 4 minus square root of 9 minus x squared. All right. This seems all well and good and such. What about our domain? Again, this one, the domain, I'm going to write it up here so we always can look at it, is negative infinity to infinity. And here, the domain is negative 3, oops, these should be rounded, forgive me. Negative 3 to 3 are the only places where it's real valued. Okay, this domain, again, is restricted by the square root, so it is only real valued from negative 3 to 3. Oops, square edges. Okay, what about f times g? Now I'm making sure this is filled in. If it's an open circle, it means something different. So be very careful in your times. All right, so if I'm multiplying, I'm going to say x minus 4 times square root of 9 minus x squared. All right, taking this, we can now distribute this in here, or you could leave it so that these are in parentheses outside of the square root. I'm going to leave it outside the square root, x minus 4 times the square root of 9 minus x squared. Either way of writing it is fine. Now, this again is defined everywhere. This one will be complex. So again, my domain is restricted to negative 3 to 3. Now we have f over g. Okay? Well, f over g, this is x minus 4 all over the square root of 9 minus x squared. Now, we already know that this domain is limited with 3 to negative 3, but I've been including those. But now the other question that can limit our domain is, where does square root of 9 minus x squared equal 0? Because when it equals 0, then we have a problem. Okay? So we square both sides and we get 9 minus x squared equals 0. And then we get 9 equals x squared. And then we square root both sides. But remember, when you are square rooting, you need the plus or the minus. If it's already in the equation, like here, there's now plus or minus. When I am putting the square root, I need the plus or minus because I don't know which root is important. So I get plus or minus 3 equals x. So this function here will equal 0 whenever x equals plus or minus 3. So now my domain is limited even more because I can't have a 0 in the denominator. So now it's negative 3 to 3 without including the endpoints. All right, what about these two? Well, let's first look at this domain. This is a polynomial. So a polynomial is always negative infinity to infinity. And a square root starts at 0 and it goes to infinity when it's positive like this. When it's negative, then we have another problem. Okay, so these are my domains, and we're going to go through this pretty quickly. If I'm adding, so f plus g, that's going to be x squared minus 6x minus 8 plus square root x. And to make it real valued, this can be anywhere, but to be real valued, this has to be in a certain area. So my domain will be 0 to infinity. f minus g. From here, I can see that it's going to be the same except for this one change. And so this one change I'm going to make is x squared minus 6x minus 8, and then it's going to be minus square root x. That will not change. Oops, that's supposed to be rounded. That will not change my restriction on the domain because this still needs to be real valued. So it's still domain is 0 to infinity. Okay? I could also have f times g, and this would be x squared minus 6x minus 8 times square root x. Now I want you to remember square root x is the same as x to the 1/2. Okay, so I'm going to multiply this through here just so you can see how it looks distributed. So x2 times x square root would be x to the 1/2 minus 6x, and this is a 1 power, x to the 1/2, minus 8x to the 1/2. And this would give us x to the 5/2. Remember, if it's to the same base, then we add the powers. So x to the 5/2 minus 6, x to the 3/2 minus 8, x to the 1/2. Now, the reason I did it this way is because I want you to realize when you see a fraction, you need to remember that that fraction, if it is even, can only be defined in the positive numbers. So my domain will still be 0 to infinity. It sounds crazy, sounds odd, but think through it because this is still a square root here. And a 5th power won't be positive. If x is negative, the 5th power will be negative, and then when we try to take the square root, it won't work. Okay, think through that. Consider that because it's going to come back to haunt you if you don't think it through now. All right, f over g. This will be x squared minus 6x minus 8 all over square root x. And the domain for this thing, the bottom can't be 0. So now it's not at 0, but close to 0, all the way to infinity. All right, the other thing that we're going to deal with is a composition of functions. Composition is where you have one function inside the other. You'll see it this way. This is why I said you need to be careful that your circles, the dots that you do for product, are not open because that means this. The other thing is this is f, okay, f, and then g is inside, okay, f, and then inside is g of x. The first one is always on the outside, okay? The first one's on the outside. And this function, normally g would map to g of x, and then f would map from g of x to f of x. So this is how the composition would work. All right, so let's start with this first problem, taking f of x and g of x. Notice we're going to compose it both directions here. Let me get my pen back because it took my pen away. Okay, composing it both directions. First, f of x inside g of x. Okay, so f, g of x. Sorry, I said that backwards. It's g of x inside f of x. That's going to be f, and then this x is like a box. Okay? So whatever I put in here is going to appear in my x function here. So this is 5 minus x squared. So it's 3 times 5 minus x squared plus 1. And then I can simplify this a little bit, and I can get 15 minus 3x squared plus 1, which would be negative 3x squared plus 16. Okay, that's the one direction. Now let's compose them the other way. So we get g of f of x. That means inside g, I am going to put f of x, which is 3x plus 1. Okay, and so we get 5 minus, open parentheses, 3x plus 1. And then we're going to have to square it. So 5 minus, I'm going to keep that negative on the outside and distribute after I FOIL. Remember, with the exponent, you will need to FOIL through. So to FOIL this, I'm going to have this first term squared, which will be 9x squared. And then I have 3x times 1, and then 1 times 3x. So that's going to give me 3x and 3x. And then I'll have 1 times 1, which will give me 1. Simplifying this, and I'm going to distribute the negative now. It goes to every single term. I will get 5 minus 9x squared minus 6x minus 1. So we get negative 9x squared minus 6x, and then this 5 and 1 can go together to give me plus 4. All right, our last thing here is f of g of 3. Okay, f of g of 3. This is f g, and then inside g I'm going to put 3. So that means I need f of, and g is 5 minus 3 squared, because I'm putting 3 inside instead of x. That will give me f of 5 minus 9. That's f of negative 4. And then I put negative 4 in here, and I will get 3 times negative 4 plus 1. That's negative 12 plus 1, which is negative 11. Now, if you look at how this one worked, I want to point this out to you so that you can do it another way in the future if you so wish. Here, g of 3 and f of g of 3, we did this kind of work up here with f of g of x. And if you put 3 into this equation, you should end up with the same thing. So let's check. Negative 3x squared plus 16. Now, for x, we're putting in 3. So negative 3 times 3 squared plus 16. When I square 3, I'm going to end up with 9, and then negative 3 times 9 will give me negative 27 plus 16. And that will give me negative 11. So when I've actually composed these with x, it is letting me, rather than having to put a number into g and then into f, it allows me to take my original number and put it in this function and get the end result. All right, you guys go ahead and try composing these two functions. All right, so while we are looking at these with restricted domains, you can see here that f of x is only defined when this inside the argument is positive. So this means this is only defined from -1 to infinity. This one, of course, is defined everywhere. So when I compose these two functions, I am going to find that my domain is still limited. So let's go ahead and look at this. F of g of x. That is going to be, f of x is square root, and then I have my box that the x is, plus 1. Okay? And what g of x, what I'm plugging in for x, is x squared minus 1. Now, if I continue simplifying here, I'm going to get the square root of x squared equals x. Now, this function looks like it's defined everywhere, but we already know that the only way f of x works is if this is between -1 and infinity. That means this has to be -1 or greater. So this has to be greater than or equal to -1. So let's solve that. X squared is greater than or equal, x squared minus 1 is greater than or equal to -1. That means x squared is greater than or equal to 0. That means x has to be greater than or equal to plus or minus 0, which is the same as 0. So my domain for this function is going to be from 0 to infinity. Even though it's defined everywhere, I have to limit the function because of my f of x, because this was limiting. Oof. Nope, I did it right. Okay. So let's take a look at another example. In this example, we are trying to find an f of x and a g of x and tear these two apart. Now, you cannot say f of x equals x squared minus 2x plus 1 and g of x equals x. You cannot use the identity function. This is not allowed. So we need to look at this. The easiest way to look through this problem is to factor it. So let's try factoring this. And I will end up with x minus 1, x minus 1. So this is x minus 1 squared. So I can say f of x equals x squared and g of x equals x minus 1. Then my h of x, which is f, it's just scribbled out instead of trying to change to the eraser, f of g of x would be f, which is x squared, so this squared, and the inside would be x minus 1. There's my f and g. Neither one is simply g of x is x. The same is true here. I can say g of x is x plus 7, and f of x equals 1 over x. And then you can see when I compose this f of g of x, I am going to get this h of x. All right, I did both of these problems on the last slide, so we're just going to jump past this. Your homework is on Alex. Again, you have a test coming up on the 5th. Be sure to give me questions through Google Classroom so that I can work on the problems that you are having difficulty with. I will be speaking to you again through another video tomorrow.